In this lecture of maxima and minima, we will understand the terms maximum values and minimum values of a function in its domain. Here is the graph of a continuous function. We find that the graph is increasing and decreasing alternately. That is, it changes from an increasing function to a decreasing function. In other words, we say that it reaches a point of maxima and then the values start receding. A stage comes when it again changes from decreasing to increasing function. In other words, we say that it reaches a point of minima. The values of the function at these points are called maximum and minimum values. In this figure, we can see these are the maximum points and these are the minimum points where the function will attain maximum values at these points and minimum values at these points. Now we will formally understand the definition of maximum value of a function. The definition is: let f be a real valued function defined on an interval I or on the domain D. Then f of x is said to have the maximum value in I if there exists a point A in I if f of x is less than or equal to f of a for all x in the interval I, and A is called the point of maximum and f of a is called the maximum value of the function in the interval I. Now we will understand the same with the help of this graph. Here is the graph of any function fx. We see here that there is a point x equal to a such that f of a is greater than the other values f of b and f of c of the points b and c. In fact, you take any other point on the graph, the values at these points will be less than f of a. That is, f of a attains the maximum value at the point x is equal to a. Now we will see the definition of minimum value of a function. The definition is: let f be a real valued function defined on an interval I. Then f of x is said to have the minimum value in I if there exists a point A in I if f of x is greater than or equal to f of a for all x in the interval I, and a is called the point of minimum. F of a is called the minimum value of the function in the interval I. Let us now see the graph of one more function here. In this case, we find that out of the points a, b and c, the value of the point at x equal to a, that is f of a, is less than these values f of b and f of c. In fact, any other point you take on the graph in this interval, these red lines, they denote the interval of the function. So, or in this domain, we can see that f of a has the least value. Therefore, we say the minimum value of the function is f of a and a is the point of minimum. Now that we have understood the terms maximum and minimum values and points of maxima and minima, we have a few observations about the same. The first observation is: a function f defined on an interval I may attain the maximum value at a point in the interval I, but not the minimum value at any point in the interval I. So this can be clearly understood by the following figure. In this figure, we can see this is a graph of a function fx is equal to negative x minus 2 the whole square plus 5. Here, the function is attaining a maximum value at x equal to 2 and the value is 5. But there is no minimum value for this function. The second observation, a function f defined on an interval I may attain the minimum value at a point in I but not the maximum value at any point in the interval. Here is the graph. F of x is equal to 4x square plus 16x plus 18, where x belongs to the set of real numbers. We observe from this graph that this function attains a minimum value at x equal to negative 2 and the value is 2, and the function does not attain a maximum value in this case. Observation 3. A function f defined on an interval I may attain both the maximum and minimum values at some points in the interval I. So, here is the figure. F of x is equal to sin x defined on closed interval 0, 2 pi. We observe that here the function attains both the maximum and minimum values. The maximum value is attained at x equal to pi by 2 and the minimum value is attained at x equal to 3 pi by 2, and the maximum value is 1 and the minimum value is negative 1. Then we have observation 4. A function f defined on an interval I may not attain both the maximum and minimum values at some points in the interval I. So we can see the same in this graph. This is the graph of f of x is equal to x cube. Here this function does not attain a maximum or a minimum value. This can be made as large as possible or it can be made as small as we please. Therefore, the function does not have a maximum or a minimum value. Now that we have seen these observations, these functions will be discussed in detail in the future lectures.